gentlemen, to the panel, and we're going to start our panel discussion. So please get your Q&A ready and ready to go. So we're adding to the panel, Peter Harding is the CEO of Kelvin AI, and Sean Smiley of Stratus Computer. So what I'll do is I'll let them get settled in, and then I'll do a quick open questions to the audience, and I've got a few that I'll intersperse in here, but if anybody has any questions immediately, we'll try to get those addressed, and then we'll, if anybody has a question, we get, okay. I'll start off with first I'll direct a question to Sean Smiley at Stratus. Can you tell us some more about what Stratus is hearing from customers in oil and gas, and to that, what basic key trends are you guys seeing?
Yeah. So first of all, I'm 25 years in oil and gas. So I've been in the oil and gas industry for a pretty significant amount of time. And the dog and the guy in the truck, going to each well site to check on tank levels at tank farms, we've evolved significantly. But what we still see a lot of is a lot of sites that have multiple computer hardware, where one's running a Linux system, one's running a Windows system, and they've got to maintain these different hardware applications in the facilities. They've got the fans failing on it because the dust is blowing in, or the sulfur is eating away at the electronic components, et cetera. So what we're seeing a lot is the virtualization of those environments and combining those into one box. And that's where the Stratus box is a Class 1 Div 2 box, fanless, no moving parts, and it's built for purpose for virtualization. So you can take that Windows 2000 server instance that is on an old box. It's, for whatever reason, still running some old historic data that your facility needs. You can put that in a virtual environment, and on the same box, you can have running a Red Hat instance as well, with some ignition, applications that you want to put on. So it's the combining of that hardware that's been, kind of collecting dust throughout the facility into one virtualized box that's built for purpose, industrial, and easy to maintain, and OT friendly. I think is also a thing that we run into a lot in oil and gas. Is it's not that the aging workforce is a problem in oil and gas necessarily. It's the fact that oil and gas locations aren't necessarily in the most attractive locations. I have spent a lot of time in West Texas, and I can tell you it's hard.
You don't like Pecos, Texas?
Yeah, or Iran, or yeah, wherever. It's hard to recruit, right? I ran a $100 million company in West Texas, and I couldn't find staff to save my life. People wanted to live in Denver. They want to live in Kansas City, right? They don't want to live in Midland, Odessa. So that taking of the IT knowledge that is available in other parts of the world that's not necessarily super available in Tioga, North Dakota, or West Texas, and making it OT friendly is something that we're seeing a lot of oil and gas customers helping, or companies asking for our help in, is taking the IT technical components out of virtualizing your environment and making it so an OT-friendly person could get after that.
So, Peter, I have a question. If you want to add to that response, you can. But I know you guys played a key role in some of Sachin's, would say success story here. What types of challenges did you guys help them during the process of that initiative?
There's two Peters. I assume that.
Oh, Peter Hardy. Yeah, I'm sorry.
There are Peters on the panel.
Sitting together, of course, just to make it all the more confusing. So I'd say the first challenge is that you have to get people to believe it's possible. There's a tremendous amount of very compelling technology. Peter, you alluded to sort of some of the more recent announcements around OpenAI and those initiatives, and that's very far out and very interesting, and frankly, I agree with you, very much closer than many people realize. But there's also an appreciation that things can be different. And you need to have that belief within an organization at a senior level. You have to have it at a mid-level, and you actually have to have what we describe as a hero. Somebody at a low level who's got an idea about how to make something better. And if you can find that person and you can support them in that, whatever that goal is, whatever that change they want to make, you have an opportunity to create some significant impact. If you don't have that person, it's a virtually impossible task. And so we start with finding a hero, finding somebody who's got, we talk about the best engineer on their best day. What is that person doing? And many of them are focused on the idea of making fundamental improvements to their operation. They've got those ideas. What they lack are the tools. They lack the tools to take those ideas and turn them into action. And what we've really focused on with Halliburton and with other companies is being able to provide that tool, which is in many ways capturing what does that engineer do on their best day. And the truth is you can distill it down to oftentimes it's pattern recognition and workflow automation. If this happens, then I do this, right? And I start there, and I start with an understanding that if I can follow, here's the best path for how we're gonna run this particular operation, and I can codify that, and I can prove that it works in other places, I start to build confidence at a mid-level and at a senior level that, hey, that one hero, that idea, that person, that what they're trying to do, it can be done and it can be impactful across the operation. But to Sachin's point, the key is to start small, right? To really be targeted in what you do in the beginning. The last thing any of your best engineers want to do is sit through a digital transformation meeting, right? I mean, forget about it. They're going to do everything they can to dodge that. Rather, give them an opportunity to express what they want to do, which is oftentimes fix something and fix it faster. Therefore, they can move on to the higher order opportunities. If you can start small, give them the tool set and the support to be able to deliver, you then give them also a certain degree of credit, right? And the other part that's, I think, really important is there's a certain degree of ego with any talented engineer or operator. If they're the best, they probably think that they're pretty good, if not the best. So in some ways, if you can figure out how to take that knowledge, empower them to be able to show that impact, you're giving them an opportunity to elevate their role in the organization. So there's technology, there's change, there's just human psychology, bringing these different things together that it takes to be able to make these fundamental, to make change in these big opportunities and overcome these issues.
Okay, I feel like I'm getting
Tim,
interrogated.
Peter Manos, ARC. I loved the analogy, Peter, photos that you made with the cerebral cortex being that highest function AI
Right.
and ML. And my question is sort of a Peter Harding question potentially. It's really like, okay, the brain is a pattern-seeking mechanism. How good does the data have to be for the AI and ML to do what it needs to do? We as humans are prone to, optical illusions or pattern fitting that doesn't necessarily fit the perceptions that we think we have. So can you get like the value that you deliver when the data is perfect? Can you get it when it's less than perfect? How does it evolve along that path, if you will?
Yeah, there's no perfect data, right? So don't expect that. Expect imperfect data and plan accordingly, okay? So that's your first sort of lesson in this. You build in redundancy, much like we build in redundancy around how we make decisions and otherwise to try to come up with, hey, these are the basic rules that we're not going to go outside of, but within it, we need certain degrees of quality from an information perspective. And it, by the way, it depends on what model you're running, right? Certain cases, super simple. You can have dirty data that gives you enough of a signal to make a decision, and that's going to be sufficient. That's very much the if this, then that, pretty basic stuff, You get to much more complicated, I need higher quality data. The truth is, you're going to probably build that model somewhere else in the cloud, could be using different tools, and you're going to implement it with a certain degree of data quality metrics to make sure that it works. And by the way, if it doesn't meet that criteria, you go back to your reptilian model of like, keep it basic, right? Don't do the complicated changes, just keep it within these bounds. So you have to build in that flexibility, and that's a lot of what we do, is to understand how to create the constraints around what this, we describe it as a co-pilot, what this co-pilot can do and can't do. What information is required for that co-pilot to be able to fly the plane or not, right? To make the decision or not. And once you've laid that out, it becomes a lot more easy to try some different models and be able to understand, is this going to be a functioning co-pilot or not? Yeah.
Hi, Ravi Subramanian. Thank you again for the presentations. I really enjoyed, Peter and Sachin, your presentation and the panel discussions. And oil and gas is a very complex industry. I think, Peter, you mentioned that they're kind of 25 years behind technology adoption. And I see that you were talking about cloud adoption and the architecture. I know, Sachin, you were talking about edge solutions, I guess. So my question is, like, what use case is ripe for on-premise, right? And obviously, like, it also depends on the psychology of the customers and the industry and other things. So, and other use cases are ripe for cloud, right? Mm-hmm. So what do you see from your perspective, the ones that are ripe for edge or ripe for cloud?
I'll go first. So it's all about the right tool for the right job and knowing what you could do where. So a perfect example is a fast Fourier transform of a vibration of a pump. 20 years ago, you could not do this with an edge computer because it's just simply too much calculations. But we live in an age where computing is relatively cheap. So why can't we do so where do you do fast Fourier transforms? Well, you can't do it in the cloud because you'd send way too much data to go do that. So it has to be done at the edge. Whereas if you think of a soft sensor, there's another example where it just simply, it's going to take too long to go to the cloud and come back, and so a soft sensor has to be done locally. But then when I do, for example, uptime calculation, which is a very simple calculation, well, we do that actually at the cloud level, even though it is an edge calculation. Why? Because, well, it's just one more data point to calculate more data. So it's about using not just calculation capacity, but it's also bandwidth. How much data can you send to the cloud? How small do you got to keep that system? Because you move what you can to the cloud and you keep what you can at the edge. And it's always it's a subtle question because believe it or not, my chief programmer always says we can calculate that in the PLC. He loves saying that. And I'm like, no, we don't need to calculate that in the PLC. We can calculate that at the edge computer. Why bother the PLC? And he goes, well, but it's easy. But it's easier. It's the right spot. And then other times I find that the operations team is making calculations in Excel in the cloud when, wait a second, why are you doing that in the cloud? We should do that at the edge. So it's not always clear who's doing the calculation where. Often depends on who's actually needing it to.
Yeah, yeah. Just to add, the big company problems here. We have 10, 12 different product teams in dedicated product managers. Sometimes we have to limit the temptation of put it into the product where, based on which product manager is asking this requirement. So it's very easy. My product manager asked me to do this calculation in my product, I'm doing it, versus does it make sense to do in that product? So because over the time we create too complicated architecture if we don't limit clear boundaries per product. So at Halliburton, we mostly follow the same principle. Most of our equipment's control calculation is at edge. And anything which is closed loop, which needs real-time immediate feedback to the equipment is at the edge, not because can we do it in the cloud, but is it critical, time critical? Yes, then do it there. Don't worry, because the bandwidth is poor. You don't want to, what if the server is down? The operator can't wait for on the job, right? So all those mission critical are at edge, but then there are also some near real-time calculations, like emission calculations happening, or we have some closed loop automation. Was that automation, like how the quality of that automation calculation type, those type of calculation which we can afford post-treatment, like 4 hours of delay, 3 hours of delay, we keep it at the cloud level. So it's a delicate balance, but.
Do you want to answer?
But cybersecurity too. If you've got localized cybersecurity, I think that definitely needs to be localized versus cloud, and we're seeing more and more of that need for that. So I think that's a good use case is cyber.
Oh, that reminds me. That reminds me of the data sharing with customer. So if my customer wants data, and if I have to share it right from my edge, then IT will come in my way, right? So then we share through API, which is on the cloud, and then there is built-in, API management.
Yeah, we've
system
actually
there.
moved to the same model. When our customers want live data, it's no longer available to them. They get delayed data because we're going to the cloud, because it's not worth the cybersecurity, opening the cybersecurity doors just to let my customers see
Yeah,
something that they don't even know what they're looking at anyways.
yeah.
Okay, well, if we don't have any from the audience, I'll go to my next question.
You got one.
We got one.
Yes, sir.
So I'm Tom, and I'm from Williams Companies, and I just have a question more on the cultural side from you all and your experience there. 'Cause as an industry, we're known to be slow adopters and late adopters, and that's like a double whammy for us right now. And so at the leadership level, could you share any best practices you've had to get them to understand that they have to start moving faster and they can't wait and see to see what happens with technology?
I'll take that to start, and I know others will have their perspective as well. I think the first aspect is to highlight that to get to both the profitability objectives and now sustainability objectives, which all of these executive teams are now balancing, the existing systems are not sufficient. And why is that? Well, what we're really talking about is a multi-objective optimization, right? And how am I trading profitability of one particular line at one time with what's the carbon offset for some 2030 net zero thing that my board has now signed me up for? Like, that's incredibly complicated. But if they don't have a response, you know, to the point earlier, like BlackRock / whomever is going to be coming after them in the public market saying, like, you don't have a strategy for this. So in certain ways, the catalyst has been, hey, re-examine your opportunity here, because now if you have to have a sustainability objective and a profitability objective, you have the ability to examine this a little bit differently. And so I feel like that's at a C level, because if you can turn around and say, hey, I've got my hero here who's working at Williams on this particular line or has this particular part of the system, that if they're able to optimize, not only will it drive profitability, but it's also going to reduce our methane emissions, our carbon score by this much. You will get the attention of that C-level person who previously probably wouldn't return your email, right? So there's a little bit of like creating the right sort of carrot and stick incentive and messaging at that level, which helps get some of these projects move forward. And then to build on Sachin's point earlier, like COVID helps, right? You can point to a whole bunch of examples of how you at Williams were able to optimize parts of your operations differently and make some fundamental changes. So you're like, hey, look, this wasn't that long ago that we adapted, and look how great it is. Let's continue to sort of embrace that change and use it going forward to go after these bigger initiatives.
Just to add some color to that, I was going to mention COVID. COVID, a crisis is a terrible thing to waste. And COVID has been a boon for automation and controls. But the other one is, for the longest time, there has always been the trump card that has been used against us is safety. We can't automate, it's a safety issue. We can't automate, it's a safety issue. Now we're entering where we've been dealt our own trump card, which is cybersecurity. We have to upgrade because it's a cybersecurity issue. And suddenly that becomes the trump card back to them and saying, look, we have 5, I shouldn't say this in a forum, but we have 10 units that were built 4 years ago that are about as cyber secure as a piece of Swiss cheese. We have to upgrade them. There is no choice. You cannot tell me that we can't do this, because that's what we have. Then we get hacked and it's your fault. And so suddenly the C-suite backs away and says, upgrade. It becomes the safety trump card of the automation world, of the IT world.
A lot of the C-suite folks really rely on the field to tell them what's happening, right? They spend more of their time thinking about profit and loss statements and new acquisitions and things of that nature. And for oil and gas, 25 years in this business, I could tell you that the mantra of, if it ain't broke, don't fix it, right? It's kind of that old, my grandpa used to say it, and that's kind of how I visualize every oil and gas operator saying kind of the same thing. But what you need to identify is, and I think what we just heard from both Peters here, is that it is broke, right? And it's understanding or getting them to understand that the process is broken, that there is fractures in the system, and that cybersecurity, being one of them, is a broken component of what's happening in their facilities. So when they come back, say, hey, look, I don't want to do that stuff. It's operating, we're doing just fine. It ain't broke, don't fix it. Well, actually, no, it is broken. And it's just a matter of time between now and a year from now that someone's going to find a vulnerability and get into your facility, right, remotely or however it's going to happen. So automation from a cybersecurity is definitely a component of that. Safety, right, is a massive element. The way that we operated oil and gas facilities historically is not safe for the environment and for the personnel, both components of that. There's so many new ways with raw data and sensors and things that we can make sure that our facilities are safer. I was watching a video the other day about the tsunami that happened in Japan with the Fukushima plant. And if they had some sort of detection system, earlier that monitored that there was an earthquake that could cause a tsunami, which could then shut the plant down, quicker, sooner, et cetera. It goes back to what Peter's presentation was, it's that whole chain of communication that's happening. The executives need to know that these are the types of things that automation and this digital transformation the system is broken, and this is how we fix it, is through the digital transformation that's taking place.
Just to add additional from Halliburton perspective, what I saw in last 4 years, before say COVID, technology or digital was sort of enabler or one thing in the organization. Now it is like centerpiece of all strategy. If we look at 4 years back, our mission and value proposition versus now, on the website it will say digital is our, it is our way to achieve our strategy. So I have seen last 3-4 years increased investment in technology. There is increased awareness. Why, to back to your question, my personal opinion is during the COVID, when everything was remote, there was immediate need to do things digitally and so that I can do this remotely. And that literally triggered like, okay, I want to do this remote. Everything now they want to do remote. They want to control remotely. They want to view remotely. And there was constant need like, guys, this probably going to continue because when we come out of COVID, we still want to do things remotely. And we saw that need that this will continue, and there was sudden acceleration last few years. And now I'm happy that they see the data. Digital is helping us do safely, remotely, and probably more cleaner way. And when we feed this data-based insights, our VPs and executives, they immediately say, yeah, I think if I have to, what would it take me to reduce my maintenance by this percentage? We can feed that insight to data, and then they immediately say, oh. So my opinion is they have really seen the impact in last 4 years than before, maybe because of multiple factors.
Anybody else? We have a mic, Dan, Mike?
How much of the aging workforce contributes to digital transformation? Because obviously people with a lot of knowledge, tribal knowledge of oil and gas systems are retiring. New people are coming in. So how much of the knowledge that these people have need to be transferred so that the new folks that are coming in can do their jobs?
This is a huge driver, and it's been showing up on slides for the last 10 years around sort of the graying workforce and et cetera. Yeah, so it's been, and that's the case, right? It's not, that problem is not going away. I think what's changing right now, and what I'm actually probably the most excited about, is the tools for actually capturing and codifying that information are getting better and better. So there's been a lot of focus around no-code, low-code. The truth is, a lot of those aging engineers aren't that interested in drawing that out in a no-code, low-code platform. Sorry. What they are interested is describing actually what Peter put up there, which is like, this is what I want to have happen in this particular point in the process, right? If we see temperature go above this, I need these 4 things to change, okay? We are getting to a point where that is possible, where you can take that and that gets converted into Python, right? And that type of conversion allows for a completely different way for your best engineers to be able to describe what they see and then have that turn into something that becomes valuable to the organization on the longer term. Because I think as we all recognize, you lose your best engineer from this particular plant, the quality goes down, right? So what are they seeing? If they can just describe it in free text, at some level, you're going to be able to go back and find what that relates to and put it into some sort of controller. But they need to be able to express it in a way that's both safe for themselves, that actually also gives them a little bit of credit, because at some point, some of these guys are also like, hey, I don't want to share, because this is my knowledge, and I have to protect it. So you have to create a culture that's a little bit more open, but it's in that process of codifying what they know that you're creating something that has a much more lasting benefit. And there are ways to do that today. Again, the technology's there. It's really a matter of being like, once that exists in an application, okay, cool. Are we going to let that application run and make these changes? And if the answer is yes, you're going to get a Halliburton type of experience.
You want to follow up on that? No. Okay.
Yeah.
I'm going to address this one. So it's all about the tools we have around us. So if you are let me go with my image, the Dolly example, okay? If you wanted to create an image 350 years ago or 400 years ago, you needed to be a painter, you needed to study art, but then you needed to learn how to make your own brush and make your own paint because there wasn't a store to buy it. And then we had progressed a couple of hundred years, and now all you need is a brush and some easels, but you need to learn how to make the easels, and you need to go through art school. Well, okay, 40 years ago or 30 years ago, all you needed to do was run down to the store and go buy brushes and paints, and you could buy cheap ones, and suddenly the skill set to be an artist is shifting. Then it became digital photography and understanding that. And then it became Photoshop, and it became understanding Photoshop to become an artist. So it's not that artists stopped existing producing images, it's the tools that they created and what their skill set is has changed. So it's not like Dolly could still be used to generate art, but you still need someone who's creative and innovative to know how to use those tools to generate that. So Dolly's not going to replace an artist. It's just going to be the next tool in their arsenal, because very few artists today know how to make their own paint.
Great. Well said.
Okay, I got a quick question here for Sean. Sustainability has obviously, it's the theme of this, one of the main themes of the show, has become much more of a global focus. Where do you think edge computing fits into the oil and gas sustainability initiatives? What role can it play?
Yeah, so just going back to what I said before, you just reduce the number of machines that you have, right, in a facility. That, from an environmental perspective, is beneficial. Remotely accessing the assets from cloud to edge eliminates people needing to drive to this site. So there's a safety and sustainability component to that. So I would say just the reduction of the actual physical hardware and virtualizing and having it easily accessible remotely is a pretty, I don't know how you add that number up, but it's a pretty significant amount of savings that you have in fuel waste and things of that nature. So that's really where we see the sustainability on the edge compute side. That's maybe more the more physical side. I don't know if you guys have any other thoughts on sustainability with edge.
I mean, the only comment to make is in the sense of going back to my brain model there. If you took out an edge computer, then you're either going to be doing everything in the PLC or everything in the cloud, and that has strongly limited. A classic example is if you have two vessels that share gas, you got to split the gas and then rejoin them, and you have two control valves in the front. That is a classic example of something that can't be calculated in a PLC, because it's a linear algebra problem, but in Python it's literally 4 lines of linear algebra. I mean, it's literally 4 lines in Python and impossible to do in a PLC. And so if you run into that problem, you're either going to have to send it all the way up to the edge and come back, or you need an edge computing device.
Okay, I don't see anybody else. So Peter Harding, I've got a question. In terms of like working with Halliburton on this project, what are the next steps regards to the impacts you were able to provide? What's coming down the pike?
So a lot of we have to be a little careful, I think, in terms of this. But there's been a huge amount of effort at first to capture kind of the co-pilot concept. So like, what is the best practice of the best engineer, and turning that into applications. What is happening, and Jeff alluded to it in the Q1, or the last quarterly earnings update. There is more movement towards closed loop control that's happening, and the ability to take these applications and actually making them into active control decisions. And that is something that is core to what we do. It's a lot of the reason that we've been successful, I think, in partnership with Halliburton. And it's recognizing that more of this can be done at a software layer than maybe some folks realize. That historically, a lot of the traditional controls folks have put that in the PLC and have taken that as an approach from a hardware perspective. And our view is there's this kind of emerging kind of action layer where you can take these ideas and you can turn them into applications that can actually make control decisions and close those loops. And that becomes very powerful in terms of being able to also get scalability and impact across a broader organization, which is really what we're trying to do with Halliburton.
I guess my sort of a question, again, back to Sean, is what role do you see edge computing playing today and going forward in the future? Just kind of maybe it's sort of a summary of your previous thoughts or comments.
Yeah, no, just to summarize that, first of all, cloud's not going away. I remember when we first had conversations with customers like BP, Chevron about cloud, 10 years ago, it was no way, because we don't control and own the data, and we don't know where that data is, and that's our most valuable, components. Now everything's cloud friendly, right, and private cloud, and however these companies, we're going to continue to see evolving into the cloud for so many reasons. But there's still a latency issue of communicating data to the cloud from the facility and getting that real-time communication that is needed for vibration monitoring or whatever it is. So you're going to always have to have something that's localized to the facility that's providing that real-time analysis or feedback, and working in concert with the PLC, and then propagating whatever's necessary up to the cloud, and the cloud responding back to it. So, I know edge is like one of those big buzzwords that that we hear a lot about, but there's a reason for it, and there's a real need for edge computing. And I think that as cloud becomes more and more prevalent, you're going to continue to see more and more edge. We have people ask all the time and say, Sean, if everything's going to the cloud, edge is going to be, it's going to go away. Like, no, actually, it's the opposite. The more we see more cloud implementation, the more there is a need for localized edge compute, and it's beneficial for us in that regard. So, yeah, I don't see edge getting any less important. I think that we're just going to find ways to add more and more applications to it, and more useful use cases for edge computing in the facilities.
Let me put it this way: Would you get into a Tesla that was only driven by a cloud computer or an edge computer?
Yeah,
That's a good. That kind of basically sums up my belief. Has always been that I see both cloud and edge playing a role.
Yes.
It's a lot of this stuff is everybody thinks it's going to do this and that, and I think that's you got to get back to reality about how things are going to progress. So. And the last few minutes, we started a little bit late, so I think since I have the next session, I'll take the command decision. We're going to go over a little bit if we have to. But I'd like to ask each of the folks just to, give a quick thought about what would you like the people that were here and anybody in the audience in perpetuity to take away from this? What kind of main theme or takeaway would you like to just quickly, 30 seconds or 40 seconds or something like that?
I think what I want people to take away is it's possible. It's possible to actually really innovate and do some of these, getting much closer to, we haven't talked about autonomous operations, but the path to get to that is real. And it's about starting now, though, with the first thing you have to do, kind of carrying on one of the driverless car analogies, like Waymo still has a lot of people sitting behind the wheel driving around Palo Alto capturing what decisions are being made in that vehicle, right? And so it's learning from the existing operators, engineers, the experts, to codify as much of that information as possible. That becomes feedstock for what you can then do once you apply different types of machine learning, AI, and more of these advanced principles. So continue to do the work to capture that information, get it out of spreadsheets, get it into Python, get it into places where it can be used, and then you can start to have some really incredible transformation in this industry.
So I'm going to compound on that to finish to continue the story, and going back to that auto configuration programming problem. Don't be afraid that, again, with the self-driving cars, it's probably still a programming problem. You know, your first project you're going to do will be programming, will be intense, but then it needs to get to a configuration problem where we can replicate and reuse that same technology over and over again. And then don't worry about the last step, which is we're going to plug and play and it'll auto-configure. So it's going to be a journey to get there. And don't be afraid that your first project is going to be a lot more intense than your second and then third, and then it will accelerate with time.
Yeah, I would just say embrace others' stories and ask a lot of questions like you all about their digital transformation and their journey. And you're not alone. You don't have to go on this journey alone. There's a lot of folks out here, obviously, in these conferences and within your own network. And in industrial automation, we're a very close-knit group of folks. I'm sure you've run into 10 people that you've seen in the past, 2 hours that you've talked to for years, right? So embrace what their journey has been, ask questions, utilize whatever knowledge you can gain from them as well. You're not in this alone. And I think collectively, we as an industry in industrial automation, we're all working towards this common goal of making things simpler, safer, more efficient, and these transformations that we're talking about in oil and gas specifically, embrace others' stories and see what you can do to improve upon them.
We are not alone, and neither of us or most of our companies are not born digital. So my experience is, for those of our companies, we have to start small, deliver value, and then improve on that small incremental value. So that would get us longer versus we will see, oh, I'm not born digital and there are so many things to do, and we just get lost into where to start. So start somewhere, you will see immediate value to the operation, and then that would open up a lot of other opportunities and build on top of that. And invest a lot in data backbone. That's gonna create huge value, data backbone.
Well, I want to thank all the audience for being here and staying with us a few extra minutes, and I'd like to thank my great portfolio of speakers and panelists, and appreciate, hopefully you'll stick around for the next session on drones and a little bit of talk about robotics, so thanks very much.
Thanks, Ed.